Hey pre-calc friends, I'm going to do a little bit more on vectors today, but to sum up so far, here's what we know. You guys have done a really good job on this so far, and I think this stuff is, like I said, pretty user-friendly and pretty easy to play with. So with vectors, so far what happens is, I've given you a vector, say a comma b, and that is going in a horizontal direction of a and a vertical direction of b, and right now you can do two things with that. Here's what you've learned. You can, for example, find the magnitude. And you know how to find the magnitude by doing Pythagorean. A squared plus b squared equals c squared. Or I often say, use Pythag for the mag. So right now you can find the magnitude by using Pythagorean. Good, you get a length. You get an actual number. But then you also know how to find the direction angle, which you learned in the last video. And that's our new formula that uses the tan inverse of the b over the a. So what's really cool that you can do right now, for example, is if I give you the vector 3 comma negative 1, we can do everything. We can find the magnitude and we can find the direction angle. Let's do that really quick as a quick review. All right, so here's your a, here's your b. All right, why don't we give this vector a name? Why don't we call this vector u? All right, so if I want to find the magnitude, I would say that the magnitude of u, remember the absolute value notation, the magnitude of u would be the square root of a squared plus b squared, which here would be the square root of 3 squared plus negative 1 squared. Make sure the negative is inside the radical. Inside the parentheses. All right, this would be the square root of basically 9 plus 1, which is the square root of 10. Sometimes when we work on real life problems, we'll ask for this in a decimal, but for now we can just leave it as a radical, and he is completely simplified. So there's your magnitude. Yay. All right, then we can go over here and find the direction angle over here on the right hand side, and that's our tan inverse formula that's up here. So why don't we plug that in? All right, theta. The direction angle should be the tan inverse of b over a. Okay, so if I put the tan inverse of negative 1 over 3, I should get on my calculator about negative 18.4 degrees. Oh, good. Okay, but remember, we can't keep that answer because he's a negative. So remember how we fixed that last time. Let's check our quadrants. So over here, this tan inverse gave me quadrant, well, negative 18.4. That would land me in quadrant 4. But if we go back to our original vector from the beginning, where is 3, negative 1? What quadrant is that in? If you imagine graphing that in your brain, that's also quadrant 4. Okay, good. So he's in the right quadrant, he just can't be negative. So this is where we just find coterminal by adding 360. So that angle is actually 341.6 degrees. Okay, so he's a length of root 10, and he's at a direction angle of 341.6 degrees. So to sum up, you now can find two things. You can find the length of a vector, and you can find the direction angle of a vector. What we're going to do today is go backwards. What if I give you the magnitude? And what if I give you the direction angle? Can you go backwards and now give me the original vector? What would this be? And that's our goal. Before it was the other way around. I gave you the vector, you found magnitude, and you found the angle. But now we're going to go backwards the other way. What if I give you the magnitude and I give you the angle? Can you give me back the original? Okay, in order to do that, let me give you two really important formulas off here to the side that you can write down. So I'm going to tell you that for a, in order to find the a value, we're going to use trig here. And it comes down to triangles, but I won't bore you with all the details. I'm just going to jump right to the formula so you can memorize it. To find the a, what you're going to do is you're going to take absolute value of your vector, but it's not absolute value, right? It's magnitude. So find the magnitude of your vector, take that, and you're going to multiply by the cosine of the direction angle. So for the a value in the actual vector here on the left, you take the magnitude times the cos of the direction angle. Let's keep going, and then we'll plug them in and see if it works. To find the b coordinate of your vector, you take your magnitude of the vector and multiply by the sine of theta. That's actually kind of easy to memorize because remember, a is almost like, if you think of a coordinate point, it's almost like x, and b is almost like y. And remember how we always memorize that x and cosine were related and y and sine are related. So this is great because this means that we have our magnitude, which is right up here, and we have our direction angle theta, which is right up here. So that's where they would plug in. Shall we try it? Let's try it and see if we actually get the original vector back out. So the a component of my vector would be the magnitude of u, which is root 10, times the cosine of the direction angle, which was 341.6 degrees. If I keep going, let's do the b component, and the b component would be magnitude, which is root 10, that's the length of the vector, times the sine of your direction angle, and that was 341.6 degrees. Now let's put these both in the calculator and actually see what we get, maybe round to the nearest tenth, and how close are we to the original. Do you remember what the original was? Right over here, 3, -1. Let's see how close we get to 3, -1 as our a and b. Okay, so let's plug in 341.6, and I'll take the cosine of it, and I'll multiply by root 10, and I get actually I get a lot of zeros, so it's basically 3.0. That's awesome. That matches exactly what my a value is down here. Let's try the b value. Let's do 341.6. Let's take the sine of it and multiply by the magnitude, which was root 10. And I get basically -0.998, which if I take both of those and basically round them, I get this. So this is a great way of going backwards, and this is going to help us when we move forwards to do this for real life problems, where if I give you the magnitude, I know the length, I know how far I'm going to travel, and I know the direction angle that I'm traveling, you guys can write it down here in component form. This is backwards what we did before. Let's try one more. How about if I give you a vector u, I'm going to say the magnitude is 4. And I say the direction angle of my vector u, direction angle theta, is about 73 degrees. Your job right now is, can you come up with the original component form vector? And just refer back to your formula that we learned on the previous page. Go and try this on your own, guys. Plug into your calculator and give me maybe 1 decimal place, nearest tenth, and then we'll check our answer in just a sec. All right, folks, let's check and see how you did. I'm going to take my 2 pieces of information. I know that the a component should be magnitude of u times the cosine of my direction angle. Magnitude is 4 times the cosine of the direction angle is 73 degrees. If I plug that into my calculator, the cosine of 73 times 4, I get about 1.2. Okay, that's my A. How about B? Formula is the magnitude of the vector times the sine of the direction angle. Okay, magnitude was 4. Sine of direction angle was 73 degrees. Okay, same steps. And as you do these more and more in the calculator, you can just sort of cut and paste your steps from the calculator and it'll do it for you. I get about 3.8. So my final vector, given these 2 pieces of info in component form, this is the vector 1.2, 3.8. Let me show you why this is right. Okay, let's pretend I'm going to take this info here and graph it here on the axis. Okay, I need to be a magnitude of 4, which means my arrow needs to be a length of 4, and it's going to be at about 73 degrees. Okay, 73 degrees is in the first quadrant, and it's probably about here or so. Let's say that's about a length of 4, and that's about 73 degrees. Well, can you take your vector answer in component form? And does that look like I just graphed the point 1.2, comma 3.8? Yeah, it actually really does. It looks really, really close that I went to the right 1.2 and up 3.8. Okay, so again, the point is, if you're ever given the magnitude of a vector, how long it is, and you're given the direction angle, which way it's going, you can use these brand new formulas here using trig to find the vector in component form. 1.2, comma 3.8. Good job, folks.